Today we're going to do the quotient rule. It's not any harder than the product rule. It's just taking the derivatives and rearranging them. Okay, so the formal definition of the quotient rule is G prime minus F, wait, no, sorry. It's G F prime minus F G prime all over G squared. Okay, so an easy way to remember this is the low D high. So this is our trick. We have low D high minus high D low all over low squared. So this is how I remember it. I don't remember this, but if this is what you like better, you can do that. So it's pretty much the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So notice the bottom isn't the derivative, it's just G squared. But I like low D high minus high D low over low squared. Low D high D low. Okay, so let's just go into it. So we can do F equals 2x squared, G equals 3x plus 1, F prime equals 4x, G equals 3. Right, so we just split them from our top and our bottom. Right, quotient means like fraction, so top and bottom. So for this we're going to do G 3x plus 1, F prime 4x minus F 2x squared times G prime, oh I forgot the prime there, all over G squared. And then we're just going to simplify it. So this you need to distribute. We have 12x squared plus 4x minus 6x squared. The denominator stays the same. Usually we want to put these in factored form. That's probably the best. So we have 6x squared plus 4x all over 3x plus 1 squared. So we can leave it like this. Or we could pull out a factor. So 2x leaves us with 3x plus 2 all over 3x plus 1 squared. Alright, so for this one, I'm just going to straight do low D high D low, just in my head. So I have low D high minus high D low all over low squared. Right, so a lot of you got that far. We're going to pull out greatest, so you can distribute and then pull out, or you could just see it right away. They both have this 3e to the x, and they both have a 2, right? So we're going to pull out a 6e to the x. We're left with x minus 1 all over 4x squared. And then we could reduce this to 3e to the x, x minus 1 all over 2x squared. So that's the same as what a lot of you got, just a little simplified more. What? Because it's minus, this whole thing, we pulled this whole thing out, I got minus 1. Here, I'll write it. So you guys got it right, you just want to simplify it a little further. Obviously the important thing is the quotient rule, but all your algebra is rushing back at you, screaming at you from the past. Simplifying, factoring, distributing, all that good stuff. Okay, so for this one we have low D high minus high D low all over low squared. And make sure you have this in parentheses with the square. If you just put the square on the 5, that doesn't work. You can distribute this cosine, but it doesn't really matter. You could keep it like this because it doesn't simplify much nicer. Or you could sort of write it like 2x squared cosine x minus 5 cosine x minus 4x sine x all over 2x squared minus 5 squared. So a few people, so the sine x, you can't write it like 4 sine x squared. You're not allowed to do that because the sine is referencing just the x. So the 4x is just separate. So you have to put it in the front, or you could put it in the back. It's normal to put it in front like this. That's probably the best way to write it. Okay, and then the last one, there's two ways to do it. You could do the quotient rule, or you could do the power rule. So the power rule, you can rewrite this as a power. So you could do 3x over 2x squared plus 1 over 2x squared. Because remember, when you're adding fractions, you need the common denominator. So if we split this back up, we'd have that common denominator. We could rewrite this as 3 over, we could rewrite this as 3 over 2x to the negative 1 plus 1 over 2x to the negative 2. Then we could just do the power rule. So we have negative 3 over 2x to the negative 2 minus 1 times x to the negative 3. So that would be written as negative 3 over 2x squared minus 1 over x to the cube. Okay, so this would be using the power rule. So I want you guys to do the quotient rule and see if you can get it to match. And you can be able to check if you got it right. So pause the video. All right, let's do it together. Okay, so we have low d high minus high d low all over low squared. So this is 6x squared minus 12x squared minus 4x all over 4x to the fourth. And so this you would, let me do it over here. We have negative 6x squared minus 4x all over 4x to the fourth. And then we can break it up. Negative 6x squared over 4x to the fourth minus 4x over 4x to the fourth. And then these simplify back down to what we had before. Negative 3 over 2x squared minus 1 over x to the third. You could also write it as, you could just go back up to this one and you could pull out like a 2x. So we have negative 3x minus 2 over 2x to the third. Few correct answers. Okay, so now we're going to do this one with the table like we did with the product rule. So it looks sort of icky, but it's not. So we have low d high minus high d low. Make sure you don't forget that 3 there, because the derivative of 3 times g of x is 3 times the derivative of gx. All over low squared, so we're going to have 9gx squared. Actually, let me just put that on parentheses so it looks easier. And then we just plug in for 2. So g of 2 is negative 1. F prime is negative 2. F is 4. And then we have 3. And then g prime is 2. All over 3 times g, negative 1 squared. So we have 6 minus 6 times 4 is 24, all over negative 3 squared is 9. So we get negative 18 over 9, which is negative 2. Alright, so try number 6 once you copy down number 5. A trick for this one is maybe put this negative sign up here for the g of x. Or you could just do the negative at the very end. Whatever you want. Okay. So we're going to put the negative just on the top. So we have low d high negative g prime x minus high d low, so just negative f of x all over low squared. Okay, so f of x is 4, 1 minus 4, g prime is 2, negative 2, g is negative 1, but it's negative, so negative negative 1 is just 1. Negative negative 2 is just 2, all over 1 minus, that's a 4 squared. So this is negative 3 times negative 2 is 6 minus 3, or minus 2. All over negative 3 squared is 9, so we have 4 over 9. Okay, so one last thing I want to clarify. With number 6, it's a little tricky because I use f and g. But don't get confused with like this, right? G and f of prime. This isn't saying use g. It's saying use the bottom part, right? So when I'm saying low d high, I'm saying whatever is in the bottom of the fraction, whatever is in the low part of the fraction, right? So this is high, like up high, and this is low, like down low. So when I say low d high minus high d low all over low squared, I'm just saying whatever is on the bottom of the fraction. So bottom of the fraction times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. So even though this uses f and g here, the bottom part is 1 minus f of x, not g, right? So this is just generic. They're trying to make variables for it, but it's easier just to separate it into high and low, I think. And we do low times the derivative of high minus high times the derivative of low all over low squared.